Now here we have this 1/3. That means we're going to compress by 1/3. So our basic points, this does not move it at all. So the domain still runs from 0 to infinity. But we had the point 1/3 -1. Now it's 1/3 -1/3. We had the point 1, 0. Now it stays the 1, but 0 times 0 is still 0. And we had the point 3, 1. Well, it stays the 3, but it compresses to 1/3. Our 9, 2 out here becomes 9 2/3. So this becomes a much flatter graph. Didn't get my curve there. Projections from 2010 to 2050 indicate the percent of U.S. adults with diabetes, both diagnosed and undiagnosed, can be modeled by this equation. The percent equals negative 12.975 plus 11.851 times the ln of x, where x is the number of years after 2000. We want to graph this function. We want to answer, is it increasing or decreasing? And what does that mean in the context of the application? What does the model predict the percent of U.S. adult diabetes will be in 2022? And use the graph to estimate in which year this model predicts the percent to reach 33%. We're looking at graphing the equation about the diabetes. We have negative 12.975 plus 11.851 ln of x. Since we had parentheses, we'll close them. If your calculator doesn't have parentheses, you'll be okay. These are percents, so we'll do 0 to 100%. And here's my graph. The thing they asked to do is to graph the function. We've done that. Is the percent increasing or decreasing? Well, we can see that it's increasing. And what does this mean in the context of the problem? It means more people will have diabetes. 50% of you adults will be in 2022. This will be x equals 22 then. So P of x will equal negative 12.975 plus 11.851 times the ln of 22. Grabbing your calculator, we find out that that is 23.66% of U.S. adults will have diabetes by 2022. Now they ask us to use the graph to estimate the year in which this model predicts the percent will reach 33%. So we'll use y2 equals 33 and see where they intersect. When the percentage of those diagnosed with diabetes will be 33%, which is a third of the population. We'll go to y equals, we'll fill in 33, and look at our graph. Yes, it does intersect during that time. So let's find second calc. We want the intersection. Okay, this time y equals 30 is not quite, x equals 30 is not quite there, so I'm going to guess 50. We'll find out it's 48.396. This is where they intersect, and we notice that we use this from 0 to 60, and this was 0 to 100 because it was a percent. The year that it happens, 48.39, so 48.3 for 40, and we'll use that as 49 plus the 2000, so it'll be in the year 2049 that a third of U.S. adults will have diabetes according to this prediction. Now, the basic properties of logarithms. If the base is greater than 0, not equal to 1, the base the basic properties of logarithms. If the base is greater than 0, but not equal to 1, the base, log base b of b equals 1. Log base b of 1 equals 0. Anything to the 0 power, 0 is the exponent. Log base b of b to the x equals x. It's the exponent of this number. So that makes sense. And if we have log b raised to log base b of x, it will equal x. Remember, log base b of x is the exponent that gives you x, so that makes sense. For all positive real numbers m and n, if m equals n, then log base b of m will equal log base b of n. Some additional properties. Again, we'll have the base is greater than is positive but not equal to 1. K is a real number and m and m are positive real numbers. Log base b of m times m equals the log base b of m plus the log base b of n. That's the product property. And when you think about that, if we had x to the a times x to the b, it would be x to the a plus b. Remember that the logs are the exponents, so we treat them like the exponents and add them together. Log base b of m divided by n then is log base b of m divided by log base b of n. Remember, if we had x to the a over x to the b, that would equal x to the a minus b. We would subtract the exponents. That's what we're doing. And log base b of m to the k equals k times the log base b of m. Remember, m, this is an exponent. So when we raise an exponent to a power, we would multiply. That's log base a to the b equals x to the ab.